Our next presenter is Yahui Yang.
Hello everyone. I'm going to share my screen right now. Okay. Can I get an audio check if everyone can see my screen right now?
Yeah, we can see it.
Okay. Wait a second. Sorry, I think there's some technical issue to change the slides. Okay, so can I also have another check if you can see the slide?
Yes, we can see it.
Okay, cool. So hi, good morning everyone. Welcome to this presentation. I'm Yahui, and what I'm going to be talking about today is the understanding of engineering students' perspective on effective teaching strategies in emergency online teaching. For this project, I worked with Jerry Chen, and both of us are from engineering science, and we worked in STEP. Here's what we're going to talk about today. We will briefly talk about our background and purpose, and we also have some detailed information in method and results. And at the end, we will have a discussion part. Due to the COVID-19 pandemic, the University of Toronto canceled all in-person classes and transitioned to online teaching in mid-March. And students also moved to online learning to finish their courses as well. However, the students' perspective on teaching strategies are unknown for instructors and faculties. And also in this unusual case, the previous studies on conventional teaching lose their relevance. So in this case, our purpose can be summarized as two research questions. The first one is to determine what is the most relevant teaching strategies and tools and why they worked better than others. And the second is to know how well can we apply natural language processing and machine learning approach in engineering education research. So our data came from an online student survey, which was administered in mid-May. And the survey was to capture students' experience and challenges during the transition. Among all engineering undergrad students, the response rate was quite decent. And in the student survey, there were 3 questions asking about teaching strategies and tools. And we selected 2 open-ended questions in our analysis, which are the favorite teaching tools or strategies and the tools or strategies that did not help in their learnings. To analyze our data, we used both semantic analysis and machine learning techniques. The 2 phases in machine learning approaches are sentiment analysis and topic modeling. Oh my god. In the sentiment analysis, we used NVivo and Excel to manually organize and identify the topics mentioned in the responses. And by comparing and summarizing these codes, we generated themes to describe our findings. And as you can see on the right, this is how we coded and labeled different responses about unhelpful teaching techniques on NVivo. I think I got a technical issue to switch my slides. Can I pause here for a second and reboot the PowerPoint? Sorry, you mute yourself.
Yeah, we can wait for you.
Okay, thank you. Okay, so here's our semantic analysis. And in our sentiment analysis, we first throw our text into a glow embedding to extract features from the words. And then we throw both labels and the extracted words into an RNN model to our classifier model. And in the prediction part, we will throw the text that are without labels into the glow embeddings and the classifier models to generate a negative or positive sentiment. As you can see, there's an example for the sentiment analysis. If we have a text of breaking rooms were not helpful at all, the model will give a label of negative. But it's also the similar one for the positive one. Jerry also made a great video demo about this process as well. And we are really happy to show anyone who is interested in this process. And in the second phase, we wanted to find the word and phrase patterns and cluster them to generate some topics. To do this, we segmented the responses into a list of words and ignored the commonly used stop words. And then we applied our DA model to group the similar terms to topics and find the distribution of topics in the response. And I have to also mention the distribution, the data for two different labels were passed into the model separately. Here's what we got from our results. As a result, our model in GLOBE and RNN completes a validation accuracy of 82% and a test accuracy of 80% as well, which is about 6% higher than the 74% accuracy rate in the previous study. Our topic modeling returns the topics that are containing some keywords that can best describe our responses. Here's an example for positive responses. You can also, this topic is mainly talking about the lecture, as you can see here. And I think you can also come up with a sentence using the words in the word cloud as well. The text on the right is a quote that can best describe this topic. And I will pause for a second so that you can read the quote. And similarly, we got this example dominant topic in the negative response, which is mainly talking about exam. And students also mentioned about marks and feedback as well. Here's a quote as well for this topic, and I will also pause for a second here. And showing our results from both semantic analysis and machine learning approaches, the results from the machine learning approaches really align the results what we got from semantic analysis. And from both analysis, we found students find the exam become harder due to the open book type, and also the live lectures without any recordings will make it difficult for students having time zone issues or the fast-paced issues in the live lectures. And also students perceive some increased workload as well. On the other hand, students have positive responses on the teaching techniques, like recorded lectures, synchronous lectures, so that they can ask questions right away. And they can also rewind them after the classes if there is a lecture recordings. Students also prefer teaching tools like BB Collaborate so they can watch the recordings, and discussion boards so that they can discuss with the TAs or professors whenever they have questions. So going back to our second research questions, whether the natural language processing and machine learning can be used in engineering education research. We found the benefits of this approach is that we can get an overview of the topics after running the whole model. And it's also really quick to find a course that can best represent topics as well. Also, since we have already feed our model with a bunch of data, the model can also be reused if there is a similar data set. However, there are limitations like the accuracy of the models, and we also take a lot of time to tune the model as well. And also the machine did not really take consideration of the word variation used by humans. So which is an area like we can improve in the future. So talking about the significance of our research. Pedagogically, the instructors could gain a lot of insights from the student perspective we find. And methodologically, we also provided an initial framework for using machine learning in engineering education research. In the future, there is still room for improvements on data processing and modeling to improve the model accuracy. And we can also test these improved models on the similar data, like for the future student survey. And here's our reference. And we want to acknowledge the support from Professor Evans, Dr. Liu, and Juliet from ASDAP. And here's my presentation. I'm open the floor for Q&A.
Thank you, Yahui. We have a question from Ravi Raj. Go ahead, please.
Thank you, Yahui. I thought that was very interesting work, and congratulations on the results and the process. Could you talk a little bit about how you did the training of these machine learning algorithms? How much data you had? How much, how many students? How did you label the data and those kinds of things?
Yes, like although we got one responses, we manually separated data into. We manually labeled the data into positive and negative by me and Jerry, and there are about 900, like about 1,000 number of responses which we used in our data analysis. Here we separated data into, I think it's 800, 100 for the data analysis, like the 800 data for training and 100 data for validation and 100 data for final testing. Did that answer your question?
Thank you.
Okay.
Next question is from Wei Tong. Please go ahead. Can you please unmute yourself before asking the question?
Yes. Okay. Sorry. Very interesting work, and I'm actually very impressed that you can get this done within a very short time. So my question is, if you were to accumulate these survey data from this year and next year, do you think this will change your findings, or you think just like one set of data is good enough?
I think our findings are mostly based on the research, the survey in this year. But I guess like if there will be a survey like in the fall term as well. So like we think some responses will change as well, since some instructors can improve their teaching techniques. But overall, the word terms such as specific teaching strategies will not change a lot in these cases. So like I think our model can still be used even though we change the data, but like yes, we welcome more data to help us to train the model to get a better accuracy as well.
Okay, thank you.
Does that? Okay, thank you.
So we have a question from the audience from Professor Deborah Tihani. She was asking, did the thematic coding inform the NLP?
Sorry, I didn't notice there the question. I think the thematic coding we used was an insight why we used NLP, because like we threw a lot of time to also manually coding the responses as well. So like we want to use the natural language processing to try to improve the efficiency in the codings. And at our findings, some result we got from the natural language processing and machine learning really mostly fits the codings we used in semantic analysis. Does it answer your question? Okay, thank you.
Thank you, Yahui. So that ends our morning podium presentations. Next we have grad student alumni panels coming up. So please, if you're interested, please have a look at it. Thank you everyone for joining us, and I will see you on poster presentations after lunch.